Thank you.
Okay, now today I'm sharing with you is about setting an optimum harvest goal in fishery management. Optimum harvest goal, usually we will deal with it when we deal with natural resource utilization. So it's especially the renewable resource like timber and fishery. Those are very important renewable resource for us. So how to set a harvest is optimum. And especially like for in the fishery, the question is how many boats that we have to go out to let it fishing, or how many fish we should left in the ocean, in the water. So that is something in the fishery management that we often run into. And then, so everyone will recognize this one because you are in Hawaii at least 1 year already. So who didn't eat pokeball before? You never eat pokeball? You never eat pokeball? Oh, 1, 2, 3, 4. Oh, okay. So is it because you don't eat fish? I know Sam won't eat because he's allergic to fish. You are allergic. Huh?
Are you saying before coming to Hawaii or?
Oh,
Or not?
lifetime.
Oh, no, I didn't.
Okay. Oh, okay. What about you?
I never tasted it.
Oh, he never had chance. And
Yeah,
what
I
about
never
you?
had a chance.
Pokeball, yeah.
Oh,
I ate raw fish like sashimi, sushi, but not poke. I only ate poke when I arrived in Hawaii.
oh, okay. Yeah, but well, if you had a friend, so please take him to the pokeballs. But when you eat pokeballs, do you know where this fish come from? Do you know where the fish come from? From Hawaii? When they had a size, say, freshly made or Hawaii food, do you know where those fish come from? What do you think?
I think the last semester I was in Dr. Sam Poli's class.
Yeah.
Economics 220, and then for my group we did a project on pokeballs.
Yeah.
But I never got the chance to eat the pokeball because I was missing during the tasting time.
Oh,
Yeah, but something that we've learned is that some of the fish, they come from the auction, Hawaiian auction fish market, or it comes internationally from Japan and other Asian markets. According to
yeah.
our research, but that's all I know.
Yeah. Oh, that's good. Then that means you know a lot of it, because recently they have a bill in the house, the Hawaii House, when they have the set up the rule and discussion about different policies. So one of the bill is about how to regulate the labeling, but because when they labeling the fish like freshly made and Hawaii food, but majority of them is not from Hawaii, it's from some other country. Yeah. So so Hawaii does have an auction, and then we already mentioned about the market, and then long times ago I also have a study about the poke or sashimi. When people they eating poke and sashimi, when they go into the store, they never read the really fine line, the label. Actually, if you read it carefully, especially those, if you go to Safeway and some is $20 per pound, some is $10 a pound, you will wonder if you wonder why, then you look at the label carefully, that it say is treated with carbon monoxide. So when they harvest freshly and then they put some gas to retain the colors. So when it this frozen, it still looks fresh. So if you go to the market that is $5 lower, usually it's because the treated tuna. So, but today we are not talking about the labeling and the fish market. recent research I did is about the ultimate yield of renewable resource, especially the fishery. So we had a pier here, and there's a fish auction, and then the picture you see those vessels are the long line fish vessel. They can harvest the ahi that including big eye tuna and yellowfin tuna. So you can see that that's the those dealer or the buyer is doing the fish in the fish auction, and then they will bid for the price depending on the qualities. And then, so our research question is how to decide the ultimate yield for fisheries. And then we know that because you study natural science, so you would know there has a growth curve. Do I have a pointer?
Oh, I forgot about that.
Oh, that's okay. So I can
Sorry.
see here, like this is the population growth. So let's think about small thing. If we had a fish pond like this classroom that big, at first you put 10 little fish there, they would grow, right? And they grow very fast. And when they become really big, then they will like stop growing. And then even maybe they will have small fish coming out, but then in general, the biomass will fix if there's no fishing going on. So we call this one is carrying capacity. So there's population and their carrying capacity is limited by the natural environment. So now we think about fish pond, and we can think about this environment could be our ocean. So of course, the carrying capacity for ocean is much bigger, but still they have carrying capacity. And then as long as they are natural resource, and then they have a different rate of growth in an annually. Some, like when you just had the fishes very little in this fish pond, they grow probably slow. When they're getting bigger, they can grow bigger and bigger. So in the certain age, the population is certain level, and then they will reach to the maximum growth annually. And then when you have more and more fish, then the fish growing rate each year will slow down. So they will have maximum rate of growth. So that is the biology will call them optimum sustainable yield. That is the MSY here. And then, so we can see the population is not reaching to capacity, probably is half or around half. In that level, then you will have a maximum sustainable yield. So that is, but let's introduce fisheries coming in. So now in the fish pond or the ocean, they have lots of boat coming in. In the beginning, they have some small, like amount of vessel. Slowly they fishing is earning less of money, so let's go more and more vessel. And then the population will start to decline. The fish population will start to decline. And then because assuming we started from top, that the fishery reached to the carrying capacity, so the population is getting down, and then the growth rate again is going up, and then at a certain point, that will become reach to the maximum sustainable yield. But if you continue to fishing and add more fishing boat, and overfishing will happen. So we try to not go to too much further to reduce the population. So the biologists, you study biologists. The biologists say if we want to set a sustainable, maximum sustainable yield, MSY, the biology maximum point, that the maximum annual growth, that is the optimal yield. But economists had different idea, because they think when you increasing your fishing vessel, your fishing costs will increase. It's not because it will increase, but even you use the increasing number of vessel, but per vessel, what you can catch, it will reduce. Because in the fishing pond or in the ocean, when they had lots of fish, then you can catch fish very easy, right? So even just say 10 boat, and then you have tons of fish, then the 10 boat always get lots of fish. But when you start to keep increasing the fishing vessel and also keep fishing, and then the population will decline. And then at that time, same number of boat, the total number of harvests will reduce. So in economists or biology, we'll call this catch per unit of effort. We think about effort as a vessel, then it will decreasing. Then we call it CPUE, that is catch per unit of effort. So in that case, economists said if you leave more fish in the ocean, then you will be more efficient to catching fish. So if you are not catching to MSY instead of MEY, that means maximum sustainable yield, then you will use you would have higher profit per vessel and also higher profit for the entire fleet. So that is because when you have more fish in the ocean, you would get higher CPUE and your production is more efficient. So that is a different story. So when we have the lighter green MSY, that is the references point for biologists. But for economists, they would reference MEY as their optimum yield. So when I graduate with the econ degree, I was thinking, we will every day will calculate where's the MEY. So biology will calculate MSY. I will calculate MEY. But I never get this kind of assignment. But finally, I had chance to serve in the council as in the plan team and SSC, that is Science and Technology Committee. So I said, wow, when I sit there, they would ask me, they would say, okay, now biologists say MSY is 100 ton. What about economists? You tell me what is the MEY, because we want to maximize profit for the vessel. But I never get this kind of questions. So I was just pretty disappointed because actually economists they're talking about all these things. So how to do stock assessment, they hardly talk about MEY. I was busy for like other thing, talking about what is the trade-off between like sea turtle conservation and then the fishery management and all this kind of subject. But I never had chance to come into this subject. So because it's actually is in the United States, the fishery management, they had national standard, they had 8 standards. One of it is you had to decide optimum yield. So economists say, you had to catch less than MSY in order to maximize your profit. When biology insists that let's keep MSY as a target. So in some paper, you will see they would estimate. They said now because we are all overfishing, if we set our management goal in MEY instead of MSY, some papers said they do the calculation, you will actually earn 29% higher profit for the entire global fishery. So that is like, but actually like same in our fishery management council, nobody asks about MEY. They only ask, decide what is MSY. And then, and in other fishery council, the same thing. When we go to the international meeting, they always calculate MEY, but actually in the real management, they don't talk about MEY. So I was just curious why. So some people actually is a biologist. He said, I figure why, because MEY catch less fish, but when you catch more fish, even your profit margin is less, but you would allow more fish in the market. You would allow more people going to the fishery. It's maximize your employment. So they have other benefit. But as LIMS economists, they will still say, but is it MEY existing? Is it because you sacrifice your economics efficiency to gain more employment? Or because the MEY just existing in theory? So that's my curiosity. So that's how I come into this research. I would want to say, if there's a MEY, it is existing, but according to 2018, a whole bunch of NIMS economics together to put a literature review how to calculate the MEY. They say MEY in theory is existing, but it just measurement is very difficult. So I said, how to make the measurement more useful for the management? So I go back to the literature, 1997, the Gordon-Schaefer's literature. And then what I actually see is the MEY lower than MSY, the condition, the assumption is really big. That means when you go like in any fishery, when you continue fishing, when the biomass decrease, the stock decrease, then your CPUE is linear decline. If it's not linear, if it's not linear? So because, you know, when I look at in the fishery, the real life is like, yeah, in the long life fishery, in the past 20, 30 years, I did see effort increase, number of vessels increase, but we didn't see CPUE decline. So is it because the stock's still really good, or because there has other reason? So I think I start to look at what is the catchability, because they assuming catchability is fixed. So when you time the biomass is declining, so your CPUE will linear declining. So if we say this is the linear declining CPUE as time progress and biomass decrease, you can have the orange line is linear CPUE. But what if they are decreased, but not as decreased that much as linear, that they call it, in actually biologists, they study, this is called hypostability. So when they have a hypostability, then they will have different performance of CPUE. Of course, for some fishery, then when you catch just less than half, and then the CPUE is really down. So in the biology, they study that actually like 82% of the fishery is their CPUE actually is not linear decline. It's more steady, even the biomass decreasing. So even some CPUE as biomass decreasing, time going on, and there has increasing CPUE. The reason for that is biology also tell. This is because the technology improvement and also schooling behavior. So like in the broad ocean, you have 10 schools. So when you keep fishing it, and then the density is less, but they still have 1 or 2 schools. But in the same school, the density is still the same. So as long as the fishing vessel find 1 or 2 schools, they can catch very efficiently. So because of this reason, and I want to see the simulation is like, okay, if we assuming fixed CPUE or fixed catchability, the CPUE is decreasing linear. So this one is actually the Q is improving the catchability, then the CPUE decline is less. So when the Q, the catchability increasing more rapidly, the CPUE actually is flat, even the biomass is decreasing. So because of this reason, and then I want to modify the Gordon-Schaefer model, use nonlinear catchability. So I know I put lots of equation here, just tell you that algebra, when you learn in high school and calculus, it is useful. This is all calculus and algebra when you study in high school. But I don't think we had time to go through the equation, but I would just say after we incorporate this nonlinear catchability, then we can see the MSY, MEY, their position are changing, not fixing. And so if I use simulation approach, so you can assume a different function of catchability, you can assume it as fixed or decreasing or increasing more nonlinear as biomass decreasing, then you will have different CPUE path. And then also because CPU path, then using same different vessel number to catch the same amount of fish, then you will earn different profitability. So when you have linear increasing in the fishing cost, when you have a linear decreasing CPUE, you will see the graph like that. So you will see MSY here. This is the linear. So the MSY is on the top and MEY is this one. So, but when your CPUE is hypostatic, that means they keep high, even the biomass increase. So then the profit, the maximum profit is more closer to the green line. So this one is when CPUE is constant, the cost to catch the same amount of fish, it will be overlap with MSY. So when CPUE is constant, then MSY, it is MEY. So that is the biggest conclusion that this exercise, that you will see like, okay, when you had a linear CPUE decline as biomass, then you will have an MEY that is much less than MSY. That's the orange curve. But when it is the hypostatic CPUE, then I tell myself I got to stop already.
No, you can keep going.
Oh, yeah.
No problem.
Yeah.
No.
So this one is MEY is closer to the MSY, right? Actually, and then when it is CPUE constant and the maximum profit, it is overlap with the MSY. So at that point, MSY is equal MEY. So that means if you had a fishery, they are really schooling, and then the fishery, even before they are 10 school, now become 1 or 2 school, they still catching same fish that as efficient as you have a 10 school. That means you can set MSY as your MEY because they are overlapped. That is what is the finding. But of course, there is some fishery that their CPUE is very sensitive to the biomass change. That is, example is in American Samoa, the albacore fishery. So they are now their CPUE is getting really low. Even the biologist said their stock is not reaching to the BMSY yet. So then they don't want to increasing effort, and then they see their CPUE is declining. And those kind of fishery, you probably you want to have catch less, not even targeting MSY. Is further away from MSY. So that is the conclusion. So we can define the MEY based on the CPUE performance of individual fishery. So when I want to say in the 29% estimation, the higher profit, that estimation probably is overestimate, because if they don't consider the CPUE is non-linear performance. So we have to look at individual fisheries case. So in certain case, even biomass decreasing, we will set our optimum economics goal same as maximum sustainable yield, that same as biologists. But however, in the other case, like when CPUE very sensitive to the biomass change, then we want to leave more fish in the ocean in order to keep the fishery profitable. So that is my conclusion, and that is solve the mystery that I wonder why other people didn't ask me about MEY, because maybe they already know MEY is equal MSY as time and technical progress. And that's my conclusion. And if we had time, then we can talk about fishery management, but I just add on the last slide, but I will now welcome everyone question,
Yeah.
right?